All right, now we're back and we're going to go over some of the faceting options, which I think, to be honest, is one of the most powerful options in ggplot. Before I started using R, I'd used a variety of other statistical packages. And to be honest, ggplot faceting tools, I think, is by far the most useful thing that um, I guess keeps me at R, but also keeping it as that's going to be the key sort of statistical package I'll use for the future going forward, because it's very, very useful to be able to so quickly and easily split up your data to inspect for any potential issues, but also for exploring your data at a variety of different facets or different sort of subgroupings to see if maybe there are either some issues with some groupings or maybe some individuals in a group didn't respond the same. Or say, for example, you are running a trial with a variety of different blocks and you wanted to know, is the effect the same between different blocks, or maybe some blocks that were done at a different farm or in a different location look completely different than ones that were done somewhere else. Facet Wrap allows you to very quickly do those visual inspections during your initial data analysis so that you're able to identify any of those and then be able to address them directly. So the first part of this is what we've seen already. So taking our engine size by our miles per gallon, adding the point. Now, unlike before where we were using color to separate out our drivetrain, we can just specify facet wrap for our drivetrain. And what it does is it produces a different graph for each of our different drivetrains. So if you imagine each of these being stacked onto each other and a line being drawn on them, that's what we've been doing so far. But now we've just simply broken them off into three separate figures so that sometimes when you have lots of over plotting of them, this is a very quick and easy way to be able to look at them individually and see, is there any differences? So hopefully, based off of our statistical model where we found there was a significant interaction, that would be one of the first things that you would notice, is that this has got a clear downward trend, this has a clear downward trend, whereas this does not. So that would indicate to you that there should be potentially significant interaction going on. Now, facet wrap will only take one variable and will make an individual graph by each of those. We can actually do multiple variables, but they kind of serve in an interactive way, meaning that it will take each combination of drivetrain and cylinder number and make a separate graph for that. So if we have a four-wheel drive, four-cylinder, four-wheel drive, six-cylinder, four-wheel drive, eight-cylinder, front-wheel drive, four-cylinder, front-wheel drive, there's one five-cylinder, front wheel six-cylinder, front wheel eight-cylinder, rear wheel six-cylinder, rear wheel eight-cylinder. You can see that the rear wheels only come in two different cylinder sizes. There are no four cylinders for the rear wheel drives. But basically, it's doing a graph for each of these potential interactive combinations. Facet grid can do something similar, but it can make it more like a 2x2 grid, if you will. So if I run this, what it'll do is it will have a grid where I have my four wheel drive, my front wheel drive, and my rear wheel drive. And then my columns are going to be my four, five, six, and eight cylinder vehicles. So it was like before, but instead of it sort of interacting and making an individual graph for each of those combinations, it puts it into a grid for you. So if you're looking for, uh, there's not really that much of a difference. It's more about how the different graphs are organized. But also with the grid, it's going to force you to make graphs even when there may not be data there. So for example, there are no four-wheel drive five-cylinder vehicles. To be honest, there's only two five-cylinder vehicles, which might be a mistake, or maybe they are there. But also, even then, we have no four-cylinder vehicles in the rear-wheel drive, and we are graphing that. When we did it as a wrap with an interaction, it just graphs the relevant ones and it drops the ones that there are no data for. So it only graphs the combinations that actually exist. So relatively similar, but slightly different outcomes based off of what it is that you want. With the facet grid, you can also use a sort of a dot to specify how you want your combinations to look. So for example, this is kind of like using the facet wrap, but I want to have my different combinations of drivetrain and cylinder, and that I want them to be all sort of in a single column. And this like little squiggly by a dot is giving me this specific sort of format. If I flip this around, I get this format. So instead of making it the grid where we had a like a full quadrant-y type style, this is giving me all of my different combinations, but lining them up into a single row or a single column for that grid. I could also do it in a similar manner using facet wrap. So if I use facet wrap, I don't use uh, the um, the dot sign here. I just use the squiggly like I had before. And then I can say n row equals 1. And I get the exact same thing. So it depends on which direction you want to go. Doesn't really matter all that much. Uh, this I can do facet grid, which will give me the drivetrain as a single row of columns. I could also do the exact same thing. I do facet wrap, drivetrain, and I say that my my number of columns is equal to 1. So what you'll see is that in this manner, I have my sort of title on top of each graph. And in my other manner, I have it to the side. Wait, and I have it as this before, probably. Oh, because it was grid. Sorry. We will get there. There we go. I have it off to the side. So otherwise, very subtle differences, slight preferences, whatever you want. But nonetheless, the grid and the wrap or the grid both can give you very similar things. If you wanted to have it in that 2x2 of two different variables, then most definitely grid is going to give you a much more organized structure for that. Otherwise, facet wrap can do relatively similar things. You can also do specify your scales to be what we call free. So for example, before all of our graphs had the exact same scale, so they were easy to compare across each other. In most cases, that is what you want, but in some cases, that may not be what you want. So what I've done here is I've specified that all of my scales are free, meaning that I can have a different Y scale and a different X scale for each of my combinations of graphs. So if I just wanted to look at what is the relationship, regardless of what the scale was for my graphs, then I can set them to be free. Or I could just set, for example, my X scales to be free, but my Y are always going to be the same. So here my Ys are always the same, but it automatically will scale my X to the specific range in which that particular facet has data for. So, depending on what your needs are, having the ability to change them, or sometimes if you have a categorical X, for example, and you don't have certain levels of a category for a certain combination of a facet, then you can just specify your scale to be free, which would then remove that from that particular graph. So it depends on what it is that you want, but you can specify those scales to be free or not as your needs. Bars are one not necessarily super obvious thing. So if you like bar graphs in general, ggplot has turned me off of bar graphs in general. But if you do like bar graphs, it's not necessarily super intuitive. So, in the same way with the point, you might, just like I am doing GM point, I might think, why don't I? That is because, oh, we're only specifying an X here. So Y equals highway. If we do a GM point here, you would expect something obviously like this. If we then just change it to bar, you end up not getting what it is that you want. And that is because the bar, in my opinion, tends to be just slightly odd in how it's run. So with a bar graph, a lot of times, typically what you're expecting is some type of summary value in that bar, providing a singular bar. So your options are to either produce a summary data set first. So here I'm just producing a mean for the highway variable based off of the different drivetrains. And then I specify that my bar is stat equals identity, meaning just plot the number. And then I get a bar somewhat based off of what we would expect, which is the mean height for each of the different drivetrains that we've seen before. We could alternatively not have to compute the summaries ourselves. And the chapter that you'll read will talk about adding in statistical summaries for ggplot, which gives a lot of flexibility. So we can specify our data equals our data frame aesthetic. Our X is equal to our drivetrain, our Y is equal to highway. And now we can add a stat summary where our function equals the mean and our GM equals the bar. We can also add it to our aesthetic, our color equals, sorry, fill equals drivetrain. We get the exact same thing. So instead of having to do a summary and then graphing that summary, ggplot can actually just do that summary for you using the stat summary function if we wanted. And this one is a bit flexible because if you change your mind, you're like, I don't like bars, I want points, then it gives you that option. So now we have points. And then maybe you're like, you know what? I want my raw data graphed. And I want the color to be related to the drivetrain. But then I want my mean to be a different color. I can specify the color of my mean value and plot all of my individual points. With my points also, I can do a variety of different positions for my point. So what you can see is that there's probably some overplotting here of all of the different points on top of each other. In chapter 9, we'll go over these in detail. I'll just give you one, is you can specify them to be jittered, which will move them left and right following kind of a random function so that you're actually able to see all of the various data points. You have the option to specify how it jitters. So for example, we could say height equals 0, width equals 0.2. And what it'll do is that will change how it does the jittering. So it's not allowed to move up and down. It's only allowed to move left and right. And it's only allowed to move left and right by a certain amount. So I could increase the jitter to say 0.5. And you'll see I get much more spread with that jitter at a 0.5 range. There are a variety of positions. The textbook will go into more detail about each of those positions, but I just wanted to show you one of them, and you can specify that for your singular point. And then you can see, because it's specified here, not in an aesthetic, I don't inherit that into my stat summary, which means that my summary point is actually dead on center where it should be. And while I'm here, I may as well just show you that one of the most useful summaries that it will automatically compute for you is confidence intervals. So mean, and you can do normal for normal confidence intervals, or boot if you want something robust against non-normally distributed data for bootstrap estimated confidence intervals. Error bar. So now I have my data and I can specify. It always does a really long like tails for the confidence intervals that I'm not super a fan of. But now I have my data and my 95% confidence intervals via bootstrap estimates on top of my plot with all of my raw data. So this gives you a full graphical sort of inspection of all of your raw data with your summary variables plotted on top of it, so that it allows you to see how representative of your summary variables are of your true underlying data. And I think this is a really useful tool to be able to make sure that your statistical summaries are appropriate statistical summaries of your data sets. Now, going back to bar graphs again, if you just go ahead and put in your like a regular GM bar for something, it will produce these stacked bars for you based off of your fill. So for those of you who like stacked bars, then there's a very straightforward way of doing that. To be honest, I hate stacked bars. I don't know why. Some people love them, but I really don't like them. What I much prefer is that if you quote unquote dodge the bars, so make them appear left and right. And that is what you get when you specify your position to dodge. So we're basically saying move them left or right so that they're not stacked on top of each other. And I can remove. This was going back to grayscales. Here is a simple code for a grayscale. When we can compare that to the same graph above that was not grayscaled. So same figure, but now we just move the bars left and right so that they're a little bit easier to see. So we can see right now we're just plotting the count for the different drivetrains, so the total number that appear. If we wanted to, we could say highway. Oops. And now if we do that, well, we need to just change this from GM bar is going to be to a stat summary. And then similar graph, but now it's giving us the mean miles per gallon based off of the class and drivetrain for each of the various vehicles. Just bring that back to where we had it before. Okay. So this is highlighting the jitter that I just showed you. I obviously went too fast on there. So you can, if you just do position equals jitter, it'll automatically specify the jitter that it wants. If you do position equals position underscore jitter, you get a little bit more control because you can specify what you want your width or height to be. Typo. So you can specify, and as you can see, when I do this, we get a bit more of these kind of trains of movement left to right, and that's because it's not allowed to jitter up and down on your Y variable. So depending on how much control over the jitter you want, depends on how you specify it. And if there are things that you want to check, you can always do question mark position jitter, and you can also see there's jitter dodge as another option that you can use. And it gives you the specification of what you can set for this. And then as we saw a little bit before, we can use the library ggpubber. We can make multiple plots, say plot 1, plot 2, and then using ggarrange, especially if we have a common legend, it's quite useful. You can say common legend equals true, and it will pull the legend out of both graphs and then make a singular plot. And the labels equals auto gives you the labels for figure 1A, figure 1B, common legend between the two of them with our two separate plots. So if we had different plots here, so we could say, for example, on this one, let's say I want the cylinder for P2. I could make two different plots here, and I get an A, I can get a B. You can also add titles for your different plots if you want to. However you necessarily want it, and then ggarrange is just a nice simple way of specifying them. If you wanted to, you could specify the number of columns equal to 1, and then it would graph them this way. So you can go on with however many of figures that you want. And there are also, if you read the documentation, different ways so that you could have one graph that stretches kind of two panels up at the top and then another row that has two graphs on the bottom. There are all different ways to organize them. So read those documentations if you're trying to get a multi-panel figure. And some of the text goes over that in a bit more detail as well. Okay, so that wraps up what I want to cover for you guys for chapter 9. Make sure to read through chapter 9 in detail and do the exercises as well. And don't hesitate to reach out if you have any questions.